Hey, that's a win. Let's see. Okay, Jason's got a question, a good point in the chat. We don't have anything on the HamSCIence calendar on the weeks coming up. So basically, whatever day would work best for you, Jason, would work well for us, I think.
All right, could we do maybe the second week of September?
Yeah, let me bring up my calendar to make sure we're all on got our dates the same.
So September 12th?
Let's see, I want to check my emails because Joe Zerkich was going to do a quick talk too for us one day. Let me see when Joe was, if I can find my messages from Joe. I don't have all my emails on this computer apparently. Let's tentatively put it down for the 12th, but let me confirm that by email when I get back in the house after the meeting, Jason. That be okay?
Yeah, that sounds completely fine.
Yeah.
I do apologize. I'll have to leave probably 15 minutes into the meeting or something because I'm preparing to move.
No kidding.
You're gonna
Yeah,
move?
Yeah.
Jason,
How
as a
far are you
favor,
moving?
yeah, Jason, as a
Uh,
favor, because I help with the press releases to get all the publicity out. If
Yeah.
you can send me like 2 or 3 graphs as a bio,
Sure.
I can use that for a press release ahead of time. My email is wx2r@arrl.net. Real easy.
Okay. Yeah, that
Okay.
sounds good. And
Thank you very much. Yep.
Yep. And
Save some time and it's right the first time. So
all
thank
right.
you. Mhm.
And to answer Mary Lou, yeah, I'll be moving to Los Alamos. Gonna end up at Lanel, so should be exciting.
So that explains why there's so many boxes around you.
That's right. Yep.
And where are you moving from, did you say?
Peekskill, New York.
Oh, Peekskill.
Yeah, I'm
Yeah.
currently at West Point. So
Yeah.
Are you in the military?
no, just working as a civilian, research scientist and instructor. So
It's a change of pace.
yeah.
Well, I hope you like
Sure.
it hot and dry.
I love that area much more than the Northeast, frankly. But
You should check with Bill Kate when he's on the call, because
all right.
he's down by you as well. So he's
Oh,
also
okay.
the section manager for ARL in New Mexico. So
Oh, very
yep,
nice. All
yep.
right.
So good connect. Mhm.
I'll take note of that.
Some of my friends grew up in Los Alamos during World War II. Have lots of
Oh.
stories.
I imagine, yeah, that's like maybe the most interesting time to have been there.
Right. So it's probably a little more relaxed nowadays.
Yeah, I'd assume. At least until I get there. Yeah.
All right, let me officially open the call today. Good afternoon and or evening and good night to everyone. It's the Thursday, August 15th version of the HamSCIence call. Today's call, I thought we'd do a little planning, a little investigation, throw out some ideas on who we might like to hear from, what subjects we might like to hear from, because you never know if we don't have a person, but if we have a subject, we may be able to find a person to go with the subject. So I'll obviously we're recording the meeting today as well. Nathaniel has to move the meetings from the Scranton cloud up to YouTube. So it sometimes takes a little while for him to get free up a little time to do that. But I'll also be taking notes as we're going along. So that should help, I hope. So anyhow, but we got our first offer today before we even got started. Jason offered to speak on 9/12. Another thing we've got coming up, Joe Zerkovich, who was speaking here a couple of weeks ago on sporadic E, has done took some data on the CHU reception during the April 8th eclipse. Took some audio data and has created some interesting plots and put together some statistics on what he heard and what he recorded. So at some point, Joe will be joining us coming up a little bit too. So I guess I'll give folks a chance to volunteer right off the bat. If there's anyone who wants to raise their hand and put their name in the hat for the next a couple of weeks or a couple of months even, I'm more than welcome to take some notes if somebody wants to volunteer.
Well, I got my hand up, so I'll just say I have more of an announcement to make, Gary.
Sure.
Let's say but it's research related, so if it's okay now, or if I should do
Sure,
it.
yeah, go
wait a
ahead.
couple-
Sure.
All right, so it's good news related to HamSCI. So back in, trying to think here, January 24, Nathaniel and I submitted a proposal to NASA to their HCSI. That's their, I think it's their Heliophysics Citizen Science Investigation Program. And after all that waiting, I got word yesterday that our proposal was approved for funding.
Good.
And this is good news because it gives some more money to do more research on the eclipse data that was collected for the partial eclipse and the total eclipse. But also, one of the things Nathaniel and I put in this proposal was money and to support HamSCI to kind of to develop, was the wording. One of the questions that I heard and Nathaniel had a lot of discussions about over the past year was, what does HamSCI do after the eclipse, right? A lot of the planning and the science was focused on the eclipse. And of course, unfortunately, we don't have an eclipse crossing over North America once a year or once every 2 years. So the idea was that we should try and see if we can develop HamSCI to be a bit more nimble and perhaps focused on other geophysical events with a shorter lead time than, say, several years in advance, and to develop that through this venue here and the other venues. So that was what we were proposing. And so, yeah, we got the, after 10 months of waiting, I think it was, we got the, no, not 10 months, felt like 10 months of waiting. We got the okay yesterday. Coincidentally, they had released the solicitation again for 2025. And I was lamenting to my program manager. I said, when are they going to give us news about that one we submitted back in January? And 2 hours later, I got the email saying you've been selected. So I have to make a habit of complaining that the funding agencies are taking too long more often. Maybe I'll be more successful. But anyways, I thought that I could pass that along as good news, that we'll have more support, financial support for HamSCI Science, for the citizen science volunteers, the participants, the postdocs, for at least another 2-3 years on this eclipse work.
So how long is it for? Several years?
3 years, I think. 3 years of funding. Let me double check. I have to go back and check the proposal because it's so long since we wrote it. I think it's 3 years of funding. Yeah, it's 3 years of funding. So it's funding straight through to the end of July 27. And there's funding there to support postdocs, or a postdoc, undergraduates at Scranton. And there's what we call participant support, which is money to help support citizen scientists, the HamSCI participants, to, travel to meetings or travel to visit us and that kind of stuff. So, and again, yeah, it's for doing more analysis, supporting more analysis on the eclipse work, because every time I check in with HamSCI and the eclipse work, there's more and more data sets and more data to look at. It's going to take a long time to get through it all. But also just kind of evolving HamSCI into to an organization we can look at more solar terrestrial physics phenomena on a shorter time scale. As I said, for example, the Gannon superstorm, that would be an example of, I mean, I know people were on the air and such during it, but if we had been perhaps 1 or 2 years later, we could have set up to be more coordinated in that fashion. And that's something we would want to hopefully go at and have HamSCI become.
Well, that's fantastic news. That's wonderful.
And I think it's really a testament not so much to myself for writing a proposal, but also just HamSCI, because it's perceived now by NASA and other funding agencies as a very successful program or a very successful group that's reliable and effective. So I think when a half decent proposal with HamSCI goes into it, I think it really carries a lot of weight nowadays, which is kudos to everybody here and everybody who's not here who contributes to HamSCI.
Yeah, I mean, the organization has really been built up the last few years. The eclipse and stuff gave us an opportunity to do a lot of outreach. I mean, Ed knows and Mackenzie knows and all the others who are Gary and others, Ron, who are doing a lot of outreach to the citizen science community, mostly in the amateur radio side. And you guys handle the professional science with things like CEDAR and AGU and all that sort of stuff. So I think we get the best of the both worlds.
Hey,
I think
Gary,
yes.
just to tag on to that, I sent that in an email, but I'm finding more and more as I'm doing presentations to ham radio clubs that they are at least familiar with the term HamSCI and a basic concept of what we're doing. What's interesting is I have been doing more and more astronomy clubs as I've been getting into that part of the hobby, and they almost 90 to 100% have never heard of it, have no clue what it is, and are very interested. I mean, past casual, very interested in it. So I think as we get out, we're spreading it in different directions. It's been nice.
Very good. I mean, it's interesting too. Nathaniel asked me to work on something last week. We have these little foldable, they call them zines, that the NASA asks us to fill out and populate from time to time. They're printed on an 8.5 by 11 sheet of paper and then all folded up. And of course, the last ones were focused around the eclipse. And this one, I said, well, what do we talk about? Just as Gareth said, we don't have the eclipse. I said, well, one of the things we'll be doing with our personal space weather stations is observing the passage of solar cycle 25, the most active in decades. Picture of that. A little bit how the PSWS works and whatnot, but I did add the NASA partner logo on the back. So I didn't know that a couple of days ago, but I think it was probably pretty timely that we'll give NASA a little bit more press too in our documentation. So fantastic. That brings me to a point. Let me do a screen share real quick. We were talking about promoting HamSCI. Let's see here. Some of you know, where'd that come from? We've had some standardized presentations that we've built off of and used over the years as we talk to ham clubs, so that anybody who's going to speak to their local club or over Zoom or whatever doesn't have to develop it from the ground up. So we've got a couple of new ones I just created in the last few weeks. Ron and Ed and Mackenzie and others are reviewing them right now for me. But if somebody goes to a HamFest, like Gary's going to be doing in a couple of weeks, there's a whole lot of stuff here. I mean, there's the zine here. You can print this thing off and whoop. Hopefully my screen's showing. Yeah. Hope this thing can be printed off and taken. We've got a 2-page flyer that can be printed in color and black and white that talks about what we're doing. And these things, whether appropriate for a HamFest or for an astronomy club, probably. The key is, I think, the QR codes to get back to our website. And also, I created some table tents in the past to talk about some of the specifics of some of our projects. We're looking for people to host the upcoming personal space weather stations, what we've got for existence, some of the experiments and some of the observations we've made, including the VLF stuff and the ground magnetometer and whatnot. So just be aware that if you are going to give a talk or you do want to speak to a group or somebody asked you, we got some plenty of backup information to help you out. You don't have to develop it all.
Gary, does that have material on the eclipse?
Not a lot,
Okay.
because we've been getting a lot of questions and say, okay, you guys took all this data in the eclipse. What have you found? And I think it's a little early to be talking about findings, Rhett, I believe.
Yeah, I have a specific reason to ask this. I've been asked by one of our local radio clubs, the Stars Club, which is connected with New England HamSCI, New England SciTech rather, to give a presentation. So looking for material.
The I guess what I would say to that question is I'm kind of waiting for guys in the science side of the equation, whether it's the Kuldeeps or the Garretts or the Nathaniels, say, hey, look, here's some material we've got. Here's what we'd like to talk about.
Yeah. Well, I
But
know we've
we-
had
we'll be a little
quite a
while.
bit that certainly Nathaniel has pulled together, just initial observations showing the Doppler shifts and things like that. So I think that's the sort of level I'm looking for, not scientific results per se, but just the being able to demonstrate the kind of data that we take.
Okay, I do have a couple of his presentations from the Dayton Hamvention, and I can put them in that same folder and shoot you a link into the folder, David, so you can take a look
Yeah.
and see what's there.
I may have, yeah, I think I have a preliminary one of his, but that would have been from like the workshop. But yeah, that would be the sort of thing I'm looking for.
Okay,
And I can use his, the slides, mix and match.
right. Okay,
Thank you.
Hey, Gary, is any of that
Yes.
stuff available on the website, or should we reach out to you if we need something?
I haven't put it on the website. Most of it, I kind of just keep it in that folder, just so it's in one spot. But yeah, you're welcome, Randy, anytime to ask me for a link and I'll shoot it over to you.
Okay, great. Thank you.
Can I ask a quick question here about the stations?
Sure.
So we have one of the stations at West Point, and I also intend on at some point getting one of my own. Is it possible? I know they have the raw IQ data and the Doppler. Is it possible to get scintillation data from those stations? Because that would be like a really helpful science topic to focus on.
Well, the short answer is no, not yet,
Okay, I see. Okay.
but we would like to. By the way, I've been meaning to ask, what are our connections to SynthPy and that project? They gave a presentation 2 years ago at the workshop, and I've got another science, citizen science project that's hopefully ramping up. And I know HamSCI is interested in doing scintillation and TEC measurements. So
We can get like tech and slant tech and VTech and rho T and rod and all those from the IQ data, I think, right? But not like S4 and Sigma Phi.
from what IQ data?
Like from the station, the personal space weather station IQ data.
Oh, you can get TEC out of that? You're not using GPS?
I think so, using Anthea Coster's like GPS tech program, but I'm not sure. I could be totally wrong about that.
Well, the thing is that the grapes are using Leo Bodnars that do not give all that data.
I see. Okay.
But that's the sort of thing we'd be looking into. You know, the original Tangerine was designed to have a dual carrier GPS in it for this reason. Tangerine, of course, is transmuting into a new level of project, but it still would have a capability of a high-end GPS receiver in it.
Yeah, that might be a better question for the group that meets on Monday night that's been working on the RX 888,
Right.
K9Q radio and the GNU radio stuff that runs on that.
That's where we're actively trying to define this next level of what we're calling Clementine or such.
So sorry, just to clarify, we have one of the RX, what, 188,
Yeah.
88? I don't
RX
remember.
888s.
Okay,
That is, by the way, an open source design. We're hoping to build off of that with you know, a clock reference, GPS disciplined reference and all that. And that is in the middle of the definition stage now. So you might come in on the Monday night telecons, which
Okay.
are specifically the hardware telecons, and help us define that.
Yeah, that'd be awesome. Yeah, thank you.
Sure. Yeah, because what we're trying to build from the 888 is multi-channel. 888, of course, is only single channel. And many of us are interested in multi-channel so that we can do interferometry with arrival, things like that.
Okay, interesting discussions. If I can steer it back to if we're done, if we can steer it back to the speakers a little bit. I mean, there's a couple different categories. I mean, there's folks that have done research or doing research, things to present and questions to ask. There's also some, at least on my part, some interest in some of the techniques we use to figure this stuff out. I mean, some of it to me is interesting. We've as Garrett said, we've got data here, there, and everywhere. I know that Bill Engelke was working on a funded project to kind of get his arms around some of this data, move it up to the Madrigal database that CDAR owns or manages or maintains or some such thing. I think it'd be interesting to find out what's going on with all this data. Many of us as citizen scientists have helped collect it because it's kind of gone off into a vacuum, which is fine. I don't need to look at it, but I know people are using it, but we don't know how it gets there, or what kind of thing happens. So I think there would, for me anyhow, there'd be some interest in kind of looking in the back doors of some of this stuff and see how some of these processes and things work.
Okay, Gary?
Yes.
Bill Engelke is trying really hard to meet the deadline of having it all up on Madrigal by the end of August.
Mm.
With all sorts of annotation with it and small methods of how you could download chunks of the data and analyze it in this way or that way, or slicing and dicing. So pretty soon, that should all be up on the MIT Madrigal database, and then anybody could download it and play with it. So we're looking forward to that.
All right. Well, it sounds like we need to give Bill some space and let him finish that up, and then let him breathe for a while, and then we can ask him. Kuldeep, you had a question last week. I can't recall at the top of my head, or a suggestion. You had some interest related to the data or
Yes.
the whatnot. What could you repeat that again this week, please?
So I'm interested to know about three networks, RBN, PSK, and WhisperNet, how they operate. These are continuous mode or intermittent, that kind of.
Okay. Yes. Yeah, that's right. I recall that now. So what I think I will do, I will check in with Philip Gladstone, who created PSK Reporter many years ago, and we'll see if Phil will be willing to fill us in on some of those things. And I also know Pete Smith, who's one of the principals behind the Reverse Beacon Network. So I've got at least a couple of contacts there. And then obviously WhisperNet, Rob Robinette can help us get to some of the principles there. What kind of things so I think we've got a good opportunity to hear about all three of those.
No, thanks.
Yep. All right. Any other thoughts that have germinated since we've been here today?
A name that creeps up in various papers that I seem to come across, most lately on Sporadic E, from Cornell. David, is it Heisel? KY2W?
Yes, David Heisel.
He seems to be very active in a quite significant research in areas that are relevant to us. I don't know if perhaps Gareth in particular might comment about whether he might be interested in giving a presentation on his work to this group.
Yeah, that's actually a good question. Dave Heisel, yeah, he's very active in ionospheric physics and HF and all that kind of stuff. So he might be somebody that we should reach out to and talk to.
Yes.
That's
He's
Um,
accessible, and he actually works actively with us at Dartmouth.
yeah. So would you like me to reach out to see if you'd like to give a presentation, perhaps on sporadic E and related physics to the?
Yeah,
to
that would be
us?
great if you could do that, because my name comes across, they're gonna, I'll end up in somebody's spam folder, so.
Okay, sure, I can do that.
I appreciate that.
I'll make.
Good suggestion, Gwen.
Should I just say anytime in, oh, sorry, should I just say anytime in September or October timeframe?
Yeah, that's probably reasonable.
The other point I'd like to make sort of picks up, Gary, on your text in your call notice for this was, what work is going on, and what I'm sort of having trouble trying to get over now has cropped up in conversation lately. Like, how do you work with the data that's been gathered, the grape data, the IQ data? And in particular, I am still many weeks afterwards trying to follow up on Mary Lou's challenge on what on earth is going on with multiple co-propagating signals and rays. And I would hope that in several weeks' time, I might be in a position to sort of give a bit of a discussion talk. No findings, but discussion. Tonight, would you indulge me with 2 slides? Because I'd really like to know if somebody can tell me, that's a dead end, but talk to whoever.
Oh, absolutely. Please go right ahead.
Okay. So as a reminder, this really does go back to Mary Lou's multiple rays or multiple modes being seen during the eclipse. So it's relevant to the eclipse topic, which we've spoken about, and specifically 25 megahertz WWV to Nathaniel. So it's 1 hop, 2,500 kilometers, 25 megahertz. The band opens at this time, just before 1430 UTC, and there are 2 rays. You could just see them there. And this is just an expanded view of the spectrogram on the PSWS database. But there are actually 2 traces there virtually all the time. And then the 2 traces do a squiggle and come together at the end. And so my challenge is that I am absolutely sure that the 2 rays are because of we have low rays and high rays propagating on this path at different angles of arrival that have since been reflected at different heights. Now, my challenge is moving from the spectrogram to digital representation of the peaks for, say, the low ray and the high ray. What is the value of the Doppler shift? Not an image as in a spectrogram, but the value of the Doppler shift for the low ray and the high ray. Computing the FFT is easy. So this is just for the 1 minute at 1802 UTC on the eclipse day. Many weeks were spent trying to find algorithms, combinations, procedures where I can pick out the real peaks. The first one is easy at minus 0.283 hertz. But these, I need to ignore them. They're just they're inflections. They're sort of noise on that main peak. The real second peak is down here. So the software to be able to look at Doppler spectra and find peaks to within a few millihertz, that's challenge A. Anybody working on that? Challenge B, once you've got that done, is to then assign these peak Doppler values to either the low ray or the high ray in time. So this is the time of that spectrogram. They start together at exactly the same Doppler value, and then they differ because one is going down, the other one is going up. But at times they come together and you have this mishmash of both rays having nearly the same Doppler value. How do you trace an individual ray through this mishmash of similar values so that when you emerge and they separate, you've still got the low ray and the high ray properly assigned to each other, and then they come back again here, they come back here, or, clearly I'm getting things wrong, and so on. So I ideally like to know if any of you know of anybody working on that challenge of identifying the Doppler shifts for multiple rays into digital form and then tracking multiple rays as digital values. Thank you.
Yeah, that's a good one.
Hey, Gwen,
Yep.
while people are thinking about an answer to your question, if there is one, can you help me? I just watched your presentation from the June 27th meeting. Can you please help me understand better what you mean by high ray and low ray? Are you talking about the angle of the ray? Are you talking about elevation? I would appreciate it.
Okay. When you have the band opening at a frequency that is above the critical frequency at the time, so certainly it would be for 25 megahertz, then you have two ray angles that can arrive at a fixed location. One that has been reflected fairly low in the ionosphere will have a low takeoff angle, but a ray that has a higher angle of takeoff from the transmitter will be reflected higher in the ionosphere and also arrive at the same location.
Thank you. That makes sense. That's what I needed. Thank you.
Yeah.
So the word high and low has two meanings that are in fact consistent. One is the angle and the other is the altitude.
Correct. And so they have different rate of change of path length, hence different Dopplers, as the height of reflection itself may change both naturally, diurnally, as the morning progresses and the solar zenith angle increases, or artificially as the eclipse came along.
I think what helps me understand it is to remember that the ionosphere is a region. And we talk about it existing from roughly 80 to 300 kilometers or some such thing. But many times when we draw our grasp of a signal leaving a transmitter, being refracted and arriving at a receiver, we draw the ionosphere as if it's a single surface, it's a mirror. But really, if it's a region, that's right. Some things may refract off the lower portion of that region, and some may go up higher into that region and refract back down to Earth. So I believe that's what we're talking about here, right?
Yeah.
Yep.
But also the region is not a solid, it's a fluid. So the region itself is doing this.
Yeah.
It's a, yeah.
Refraction is in a continuum. Yes. Do I take it then none of you really know of somebody working on what I've just outlined?
Yeah, short answer is no. What we have done is tracked a single carrier, but not two at once.
Yeah. And Mary Lou, when you gave your talk a few weeks ago, just a few slides on the graphs, I mean, you had up to 6.
What the heck is going on there? I don't know.
How on earth you'd track that? So I'm going to be happy if I can track 2.
2 is very nice. Thinking about software to pick out peaks in a time series that has only a few like this. I don't know anybody particular, but I would suggest you look into microlensing, gravitational microlensing in astronomy, because these people have a graph that looks very much like what you had. So it's coming on, it goes up, has a big peak, goes down, has another peak, maybe a bunch of chaff, and then goes off, and they very quickly pick the 2 peaks off and go do things with them. So look under gravitational lensing,
Okay.
micro lensing.
That's just the sort of thing I was hoping for, that, you know, from another discipline, that there would be a parallel problem.
Now, one thing, I have to point out, Gwen, that you may be following two reflections, shall we say, through the ionosphere, but you could also be following two separate carriers. Because this is a problem, I know it's at my location in New Hampshire. I very often get WWV and WWVH very nearly equal level. And I can hear them both. They're clearly going to have different Doppler shifts on them.
Yeah.
How do you keep them apart?
Yeah, absolutely. I'm pretty sure that this is exactly what I showed, the high and the low, because at the start and at the end, the Doppler shifts come together exactly. As you see that pinch point of the nose of the high and the low ray.
Now, the one thing that has been done, Michael Howen developed a routine to look at the sidebands. Because the two, in this case, we have the advantage that the two carriers have a well-defined signature as to what tone is being transmitted when, and they don't transmit the same tone at the same time. So if you look at the sidebands, you can tell them apart, but not full time, but you can parse that. And a particular advantage is that even their time ticks are different. One's at 100 kilohertz, one's at 1200. I mean, 1,000 hertz, 1 kilohertz, and one's at 1.2 kilohertz.
So, yeah. And
I can actually, my ear can tell the difference. When I'm hearing both nearly equally, one is, of course, delayed by a number of milliseconds. It turns out about 16 milliseconds. And you can hear the different pitch, first the WWV kilohertz tone, and then a tick a moment later that's a little bit higher pitch.
Right. That's, of course, is going to be absent in the 10 hertz band IQ data that I'm working on.
Right, exactly. Yeah, if you're looking just at the carrier, you don't have that.
No.
Okay, well, good. Thanks.
You're muted, Mary.
So I wondered if David could sing it for us.
I don't have perfect pitch. I might be close.
I
but...
don't care.
Well, if you can't sing it, just hum it.
Without the words.
Hey, David, isn't it good to be among friends?
Yeah, indeed. I'd be much more likely to pluck it, but my violin's out in the car.
For 5 minutes, can I share what I have been up to for the eclipse
Sure.
thing? Yeah.
Absolutely. Please.
Okay. I guess this figure will be good for us. So in this one, what the presentation is, the red ones, which are hotter, they are transmitters, people who are transmitting, and blue ones are the receiving points. And the other color, cyan color, is the midpoint or the connection point mid locations. And as the eclipse passes, so let me go to one last time, and then we will kind of pass through it. Like this is the eclipse, and darkest one is about 90% of obscuration, and then it decreases by 5%. So the eclipse shadow is kind of broader, but we have a much darker region in the center. Okay, so I will just flash how the transmitters or receivers and the midpoints change as the eclipse passes through. And this is at particular frequency of 7 megahertz. Now, one point from here is we have a huge data. And second is the number of ham groups or participants are much more concentrated on the on our eastern side, and we have slightly less here and a big contribution from here. Now, once and people kind of come in and go, and there are many of them who are continuously transmitting and receiving. So from this, we went to, okay. You have seen Nathaniel's spot density counts for different frequencies. One of the figures is also on the HamSCI website, which has multiple bands. So I will show you only 3 bands here. One is 1.8 megahertz. And okay, rather than this representation, I can go to UT. Where is UT? Okay, this one. Okay, the x-axis is UT, and this is a 7 megahertz, and these are log spot densities. So 3 is 10 to the power 3. Now, what came out in 7 megahertz is, first of all, there is a stronger connections between receive and transmit points, and the range also increases during the eclipse. And the second part is this region. So this one pops up after the eclipse. So we have kind of a second, much longer distance connections after the eclipse or during the eclipse, which was not happening on the same time interval, but on a different day, which was 7th of April. So this is on the right hand side, we have 7. We don't have the much longer connections, or we can say from this figure, there is a continuity and then a gap and then a continuous spot densities. So we can say it is a second hop connection. So second hop connections popped in at 7 megahertz, which was not happening on 7th earlier day. Now this, we tried 2 different representations. One of them is, okay. So the figure which I showed just now, it has on the x-axis UT from 17 to 20 UT. Now this one has the contributions from all the transmit and receive locations across continental US. Now to bring out the eclipse effect, what I tried was, let's choose the transmit locations which are within the shadow region of the eclipse, and what percentage of shadow was there. So it is central 0 means minimum light, you can say. So this is eclipse coming in, and then maximum obscuration, and then eclipse going out from a particular station. And we superimpose all of them in the same manner. And it comes out that this second hop is coming from the transmit locations or the midpoints locations, which are within the totality, within the solar eclipse. They are not coming from the regions which are outside the solar eclipse. This is one thing, because at the sides, we don't have this second hop, this one, the beginning of the eclipse or later part of the eclipse. It is near about when we have 70-80% of totality or 50% of totality. Now, this, when we try with 2 approaches, say I can choose the location of the midpoint, or I can choose the transmit location which is within the totality. Now the figure looks different in 2 of them. This is, so let's say this one is if I choose the midpoints which are within the shadow region, how the picture looks. And if we choose just the transmit locations which are within the shadow region, I am yet to get how to interpret them. One is if we choose the midpoints, it says about the ionospheric things, but this one also should say about the ionosphere, much more biased towards the transmitters. So, and one more question was which I have is which I'm trying to resolve is although we did not see this second hop at 7 megahertz on the earlier day, we see it in the eclipse day, but did it happen because much more participants or HamSci members came in, or it has a real geophysical effect? For that, what I'm trying is let's have all the transmit locations, stations and receive locations which were continuously operating from this whole interval. Okay, let's have one minute. Where is that figure? The transmit and receive locations which are transmitting or receiving in the whole 3 to 4 hours of window, and then choose only those stations, that data, and see if this feature still persists. Hopefully this will persist and it will be because of the eclipse effect, but the next step will really isolate the huge surge in the participation or decrease in the participation. And this is also, important because if you see from this figure, the red spots or the blue spots, receive or transmit locations, they kind of change like as the eclipse passes through. There are some people who have a continuous participation during the eclipse and then some who come in and go. So I want to have a second kind of filter where the locations which are transmitting and receiving throughout this interval, I will keep them and then see if this persists. If this persists, this will be the eclipse effect, that opening of a 7 megahertz second hop will come out as a result of the eclipse. So that's what I wanted to share with you. Yeah.
Kuldeep, I have a question. Can you separate out the ones that are where the carrier is or the transmitter is WWV from a different one where the carrier or the transmitter is CHU?
Okay, so that's
I think that would be interesting to see.
Yes, definitely from the location point of view, and that's why I asked, can someone say about what are the different modes of data sets, WhisperNet or all these things, where so a better understanding of the networks will help me to realize what are being transmitted from which locations. I still lack that. Yeah, but that's a good suggestion.
I have a question. Where is the 6,000 kilometer paths hopping to?
Yeah, I can. Okay, so if I have that representation, give me 1 minute. I don't have a straight forward in my head. Okay, hopefully this will help. Okay, so this is a different representation of the same thing. Now, each open circle is still transmitting and receiving. The color scales are same. One thing is, if we have the transmitters within the totality, these are red, and if to whatever points they are connected, they become darker blue, otherwise they are open. So I guess we have more connections here on this side.
So is that a 6,000 kilometer path from the
let's
center? to
It's-
Pacific Northwest? That's
it might not
6,000.
be. It might not be. Yeah. Yeah, it
Yeah,
might
I'm
not
just
be.
wondering
Yeah,
where
it might not be. So I
where the stations are that are 6,000 kilometers away from the
But it-
center.
yeah, I need
Is
to.
this CHU?
This is 7
Yeah.
megahertz and
Megas. This isn't time signal stations.
It's not.
This is
This is HamSCIence.
Amateur to amateur, right? If it's Whisper and
Yeah,
RBN.
so it's
yeah,
not-
it has all three.
Yeah, 6,000 kilometers is greater than the
Yes.
size of
yes.
the US.
Yes, yes. So that's why I stopped kind of saying from there. So I can pull out the geographic locations of the receivers which were connected to these points, and maybe next time I can tell that exact locations where these stations being received when the second hop link opened.
I'm wondering whether they were transatlantic because they were late into the eclipse event.
Yes.
And the eclipse path went well over the Atlantic. It was just visible for a few minutes from
Yes.
Scotland in the UK.
Yeah. Yes. Now the transmitters I chose only for continental US. Much later, yeah, that's true. Around 20 UT, which is here. It was kind of outside the boundary
Yeah.
and somewhere. Yeah,
So were the receivers in Europe?
possible. And I can tell in our next meeting where these transmitters which have the second hop, where exactly they got connected.
Yeah.
Yeah. Thank you for asking that.
Well, Deep, I'm very interested still in the time transmitters. Are
Yes.
any of these people listening to WWV or not? Do you know? Are they just talking to each other, people to people?
So I combine all three networks, and I guess that in a sense dilutes the exact information whether these are WWV or these are person-to-person communications, because I have combined all three kind of networks in this plot. But I can isolate them, and that can go into whether we have standard transmitters or people-to-people contact at 7 megahertz.
So I think the midpoint is the more important thing than where the transmitter is. So I think you should be very interested in if the midpoint was in the eclipse 80% or more, or even 90% or more.
Yes. Yeah. So that's why we have these two representations. This is for the midpoints, and the other one, where is it?
That one, yeah.
This is UT. And there was one more.
Can you also do this
Mhm.
more sliced by time? I don't know.
For a narrower time interval, I mean, say 1 hour or those, or what you're asking or suggesting.
Can you slice it by latitude as well?
Yes, we can slice it by latitude also. Yeah, there are all kinds of possibilities which we can play with, and that's what I try in different, like these folders are different representations which I'm trying. Geographic span, or combining all the data, or combining just the locations which are within the totality or outside totality. So it's different combinations I am also trying. We can try that also.
So in particular, I would ask, can you produce a series of these graphs where you're first looking at people who live near Florida latitude, and then this one, and then this one, and then this one, and then you should see the time move along as their eclipse comes later and later.
Yes,
and to see if your blob, not the bottom, but the blob is moving along as well.
Okay.
Try that one.
Yes, I will try that. Thanks. Okay, I will stop sharing.
Yeah, those are some fascinating graphs. It's obvious you've put a lot of time and effort into creating them, and here we are,
Yeah.
we're asking for more. But,
Yeah, and one thing is
Sure.
I cannot run a loop over them because we have a huge amount of data. That is huge plus. But to run a loop over a million rows is also like I have to come up with ways instead of doing a loop. I should do matrix things. So that saves me some time. Yeah, that becomes extra thing to consider.
So I have another question, Kuldeep.
Yeah.
I think very good idea to look for the continuous
Mhm.
people. How are you going to define continuous?
So a way I was trying is let's in half an hour interval, say around 17 to 17:30, choose the transmit locations and go at 18:30 or 18 to 18:30. In half an hour interval from 17 to 17:30, 18 to 18:30, 19 to 19:30, see the common points, see the common transmitters.
Okay, so you would
And-
ask, is this person transmitting sometime in this half hour?
Yes.
And also this half hour?
Yes.
And also this half hour? And then
Yes.
they had coffee, so they go away. And you need another person, right?
Yeah. So if he was present in all the 4 half an hour windows, I will assume that he was transmitting or he or she was transmitting in the whole 5 hour interval, and then choose them both for transmissions and for receiving points.
Okay, I ask another one then. So to keep you busy, we don't want you
Yeah.
to be
Yeah.
bored. We want you
Sure.
to be busy. Could you also ask only the whisper data people? So
Mhm.
you have these 3, you can make them
Yes.
separate, yes?
Yeah.
So take the whisper part and ask for people that are transmitting in 5-minute intervals.
Mhm.
And there are many of them, and they're very exciting people. So look at those.
Okay.
It's a special group.
Okay. Maybe I will talk with you more about what's it. Okay.
Yeah, we should talk.
Okay. Okay. One more thing which I forgot. Okay. So okay, one more thing was there. So this all was time information, and when we had this other bands, where are they? Let's say this one, 1.8 megahertz. So this is once again the eclipse. 0 means the maximum obscursion. I need to fix the scale from, instead of being 0, it should be 1 maximum obscursion and then 0 on the either side. Okay, so here we have, this is 1.8 megahertz. Typically we don't see it because it gets mostly absorbed in the D region, but the eclipse kind of decreases the D region density and these bands might open up. Now, the opening of the band is there, we can see it. But now, if we go to the recovery part of it, or let's say the onset of the eclipse and the later phase of it, these two are not symmetric. The increase in the spot density is like the slope of the increase in the density is there, but it kind of bulged for much more interval of the obscursion, say for 50% of later part, 50% of totality, it was consistently present. And then the ionosphere kind of once again increased the region density. So there is onset and recovery. The two are not exactly same in terms of opening up of 1.8 megahertz. And it is also there to some extent. I don't know whether my eyes are playing with me because I'm looking for it at 3.5 megahertz. And I'm thinking this also has some kind of asymmetry in terms of slopes are different. So at both two lower frequencies, we have asymmetries. But when we go to the higher frequencies, I have not seen this so much. Like 7 megahertz. Let's bring it here. Oh, no, it's there also. Yeah. So there is some asymmetry in terms of when the eclipse shadow comes in and then it goes away from a particular station. The coming in part is we have a much steeper increase in the opening of some bands or the connections. And then that kind of persists even though the shadow is moving away from a station. And then persistence is, say, for 40%, or it depends on the particular frequency, at what frequency we are seeing, it will have a kind of asymmetry, or it has a kind of asymmetry, and then it once again goes to the normal behavior, like 1.8 we should not see, 7 megahertz we should see. So there is some asymmetry part also in terms of spot density.
This is
What-
lovely. This is really, really good. Very nice.
Yeah.
How many frequencies have you looked at?
I look at all the frequencies. I generate plot with a loop actually, and let's go to NGIT HamSCI. So what I got from HamSCI website was this table or this chart. So I kind of look at most of them, say definitely from 1.8 to 50 megahertz. And sometimes I cover all the bands, just repeat the loop. 1.8 to 250 for sure. Then even extending at low LF and VHF even higher. That's sometimes.
You probably have many, many fewer data points at those two extremes, though.
Yeah. Yes.
So is this a case of, I mean, Jason was talking earlier about TEC measurements and that sort of thing. So this is a case of where we would try to explain this thing by perhaps looking at TEC and trying to understand the ionization and how it maybe came and went, and that may help us explain the asymmetry and whatnot, I would think.
Yes. And TEC will definitely help. I guess more helpful will be the whole profile of the ionosphere from what happened in the lower D region and say top F2, I mean the maximum density where the densities are maximum, we call them F2. So I have desoned data from other group, and from there we get how the maximum peak densities were varying. So I believe at present, I might be wrong, more than TEC, we will be the important thing will be having the whole altitude profiles, because altitudes will definitely give TEC, but altitude profiles give one more advantage of how the gradient in the TEC, how the gradient in the electron densities is, and it gives extra bonus of having D region, whether it is how much depleted, and F region how much depleted. So both absorption and bending we can account for, but that's ideal. We cannot have altitude profiles all the places. So let's see.
Good job.
Very nice.
Thank you. Like today, I was trying to have those common stations, but the sheer the volume of data, when I ran the for loop, and then I said no. million iterations for a for loop is not good. Then I stopped it, and now I'm trying to find a way where I can do matrix kind of comparison rather than the loop. So yeah.
All right, wonderful. Thank you for presenting. That was very interesting. Any other questions for Kuldeep? Okay. Ed, did you want to take up a few minutes
Well,
about?
I'll just take a minute of everybody's
Okay.
time. So, but thanks, as I know we're a little over 5, but I just wanted to bring everybody up on just a quick update. A couple of weeks back, we talked about and actually had an outline of what we wanted to do in terms of putting together a HamSCI newsletter that we would agree that we would do on a quarterly basis. And our quick agreement is that we would start it in the 4th quarter. Mary Lou and I met yesterday, and I immediately deputized her as both editor and reporter for this project. So, but I just, and obviously we won't take the time today, but we'll talk a little bit about it once we have a little bit more to talk about. But we sort of flattened out the outline so that we've got a sense of what we need to do and how we want to do it. So I think looking at Mary Lou, so shake your head. Yes, Mary Lou, I guess. Right. So yeah, we're done, I guess, with that part. I guess what we need to begin to do is really to start to fill in some of the content pieces that we've identified. So, even though we're sort of down to 14 here, consider yourself, if you're in the chat room here right now, as perhaps part of our extended family, to provide either content or be volunteers for profiles as we get the program off the ground. So our only open issue, which is more, I guess, Gary, a note to Nathaniel, just as an open to do, is that we talked about the fact of looking for a graphic artist, so that as we get all the content put together, we know what we want to do, is that we're going to need to fill in that gap. So, I mean, we could talk a little bit about it more in a week or so, because we're not there yet, but we're going to need to have some access in terms of getting a design done so that we can make the look and feel, for the branding of it, make it look pretty good, basically there. But I think we had a really good meeting yesterday. It was over 2 hours, right? I guess in terms of just sort of hashing out what we need to do amongst other topics that we talked about. It's fortunate to have her like about 3-4 miles from the house here. So it's all good. And I think we've got a pretty good handle on it. Mary Lou, I guess, do you want to add anything here, or just because I know we're a little over time? So
No, we ought to talk about it next week.
yeah, we'll talk about a little bit more next week. So perfect. Perfect. Thanks.
Okay, wonderful. Good. It's good to hear that's moving forward. 2 hours. If that was a breakfast, you guys drank a lot of coffee too.
Yeah, it was at Panera. It was a lot of coffee. So there you go.
Ah, sheesh.
So Mary Lou's Panera, I discovered a new location.
Yeah, it's good.
Fantastic. All right, since we've hit our hour, and if there's anything else anybody wants to bring up real quick, we can. Otherwise, we'll put a ribbon on it and get back together next week. I got a few of us got some assignments. I've got one too, I guess. So, but we've got to contact a few people. So, see what we can do.
Gary, I was wondering if you wanted me to do a VLF presentation for the group, if it's relevant.
Oh, for sure it's relevant, Jonathan, because I think that's an area of mystery for a lot of us. So I'm sure we could all use some education.
Okay. If there's time next week, I should be able to join, and I could talk a little bit about VLF and some of the exciting activity that happened over the past couple weeks.
Yeah, that's great. In fact, your name had popped into my head a couple of days ago, and I thought, well, the poor guy's got to work for a living too. So, but if you can if you can pull away, that'd be great.
Yeah, I usually get home a little bit before 4:30, so I could jump on and I could start.
Okay. Yeah, we can make room for you.
That would be wonderful. I would really like to learn a lot more about this, Jonathan.
Okay, thank you. Yeah. Since this meeting has changed directions now, I thought it'd be nice to introduce some of the science, some of the things that I look at, and eventually maybe some analysis that the group could work on. I should be registering for one of my classes at Georgia Tech for my PhD program. Hopefully, if I'm not too scared to, but that should happen next week. But the plan is with my PhD research would involve answering some questions with data observed from VLF receivers, specifically the amount of whistlers received in certain locations, and what does that say about the setup and the geometry of the magnetosphere, and the setup and the geometry of the magnetosphere and the plasmasphere. So there's actually a lot of unanswered questions, at least for me. So I hope eventually to answer them, or at least figure some of that out. So I could, yeah. When there's a good day, let me know, and I'll plan a little refresher course and some of the observations, and we could go from there.
Okay, that's wonderful. It's also important too, because I think some of you may realize the DAISY 2 grant, the Distributed Array of Scientific Instruments, grant that's going through the NSF now does include, 1/3 of the instruments are the VLF reception system. So it's important that we keep that forefront in our minds too.
So how about next week, 4:30, Jonathan Rizzo?
Works for me.
Okay, if that's good for everybody, then then I will plan that.
Great, thank you.
All right,
Thank
thank you guys.
See you.
Okay, 5:11. If we call it a night, say good night, everyone. Thank you all for joining, for your participation as always, and your ideas and questions. I think, as Mary Lou said, it's important that when you don't know something, we say it, we admit it. Because questions often lead to answers, right?
Yeah, the most
Okay.
important sentence you say is, I don't know.
So, all right, everyone, have a good week. Enjoy what's rapidly becoming the end of summer here in the Northern Hemisphere, but still pretty nice. So, 73 all.
Bye-bye.
Right.